Okay, so we get to question 17, and we're getting into the really harder areas of the paper here. Okay, so it's about scrambling for points at this now where we're at. Question 17, there's probably about 29 questions, about 25. They're often in that region. So we're in the last sort of quarter, which means we're into levels 4, soon to get to 5. So here we've got a probability table, and we also should always remember with probability that everything adds up to 1, and I can see there's a gap here. So I'm bound to be asked to fill that in. But let's read it. Name our rolls the biased, it's biased, so it's not going to be the same values here, 200 times. Work out an estimate. It's an estimate because we don't know exactly right. We need to have lots and lots of n's for that, lots of numbers. Estimate for the total number of times it will land on a 1 or a 3. So this is success. A 1 or a 3 means success. But I don't know what the probability of it landing on a 1 is. So it's worth 3 marks. Let's work out first what the probability that the value of x is going to equal 1. Let's just see what, if I rolled it, what's the probability that I get 1? Now a quick way to do that is simply to say, well, it's 1 minus all the other probabilities. So take away 0.17, take away 0.18, take away 0.09, remember that, take away 0.15, take away 0.1, and what you hope for is not to have a really negative number. And let's just see, it might be syntax error. Nope, good. So it's 0.31. 0.31. Now, if you're nervous about that, you think, oh, am I right? You can just quickly estimate. Let's make that there. So it's 10, 15, it's 25, 34, plus that is 52, plus that is 70, 69. Boom, yes. So you can do a quick check like if you want to. Now, if it whirls 200 times, success is going to be a 1 or a 3. And remember, in probability, a 1 means add. So the probability of a 1 is 0.31, and the probability of a 3 is 0.18. So if I add those two probabilities together, then that's the probability of success, 0.49. For each throw, I have almost half a chance of getting a 1 or a 3. So for each throw. So if I've got 200 of these, I've got 200 of these. Okay, so simply times by 200, and it comes out at 98. So I'd estimate to get 98 1s or 3s. That's how you do question 17. Let's go for question 18. This is a longer question. It's worth 5 marks, so bear with. On Saturday, some adults and some children were in a theatre. Ratio. The ratio of the number of adults to the number of children is 5 to 2. So I'm going to just do a little bar like that. I always like doing this. And I know that I need 7 cells because there are 5 there and 2 there. So I'm going to have 7 cells. 1, 2, 3, 4, 5, 6, 7. There you go. And I know that I've got adults, so put A, and there are 5 of them, and 2 sets of children. So I'm just setting myself up. I see ratio, I do that straight away. Each person had a seat in the circle or a seat in the stalls. 3/4 of the children had seats in the stalls, and 117 children had seats in the circle. There are exactly 2,600 seats in the theatre. On this Saturday, were there people on more than 60% of the seats? Oh my life. Well, it's worth 5 marks. Maybe I can get 1 or 2. So let's just try and work it all out. Let's go back to this point here because it's quite an important thing. 117 children had seats in the circle. Okay, and we had 3/4 were in the stalls. So if I do another bar like this and say these are all my kids, 3/4 were in the stalls. So just by setting it out like this, it helps me understand how to do this. My handwriting's gone to pot recently. So I know that 3/4 were in the stalls and there's 117 that were in a circle. So I can see straight away, I can work out what each of these cells are, 117, because they're always equal. So therefore, I can say how many kids there are. I go 117 times 4, and I know that there are 468 children. Okay? Now I also know, it says up here, that I have 2 parts of children to 5 parts of adults. And if 468 occupy that bit there, then I just have to say, well, what does one cell equal? If 2 cells equal 468, divide that by 2, and I get that each cell here is 234. And I've got 1, 2, 3, 4, 5, 6, 7 of those. So now I times by 7. You can see how it's going now, can't you? I get that number of people all told. And is that more than 60% of the seats? Okay, 60% of the seats. So in maths language, you say 60% of the seats. And if that number is greater than that, then yes. If it's not, then no. So let's work that out. 60 divided by 100, because that's our percent, of means times. And then I times it by 2600. And there are different ways to do this. Oh, look. 100. There we are, 1,560. So yes, there are more. So what you need to say, you have to answer the question. On the Saturday, were there? And say, yes, there were more. And that's it.